Hello everyone, Assalamu alaikum. Welcome to mini project 6. In this video I'm going to explain motors. So there will be two videos here. The first one I will be talking about the DC motors. The second one I will be talking about servo motors. So there are two different types of motors, DC motors and servo motors. Okay, so to start with the DC motors, I just want you to know that there are different figure of DC motor. So the yellow one here is a DC motor, this one here is also a DC motor, and finally this one also is a DC motor, but they are all having different figure here. Okay, but you can use any one of them to do the connection here. One last thing I want you to know before starting here is to connect the motor directly with a movement, with a speed, with a rotation. So the motor here, the output of the motor is a rotation, is a speed, is a movement. Okay, so let's get started.
So now let's go to all mini projects file, go to mini project 6. So how to find this file? As I mentioned before, you will always find the link below the video here. What is motor? As I explained, it's all about movement, rotation, and speed. So what will be the project's outcomes? We will use digitalWrite to control the direction of the rotation of a DC motor. Second of all, you will use analogWrite to control the speed of a DC motor. And in the next video, we will do this part here.
So let's create a new circuit just to explain for you the DC motor and how to connect it in a simple battery connection here. So just write here DC. So this is a DC motor, just drag it and then double click here, and then let's add a battery. So now I need to connect this black one here with, so I will give it one click here and then go up one click. So this one I will change it to black. It doesn't matter, but I just want to make it easy to follow up with me here and to make it eye pleasing here. Okay, so this red one here, which is the other connection, the red pin, I need to connect it to this battery here. Okay, so I connect the red with the red and the black with the black pin here. Okay, so this is a very simple connection. Let's start the simulation here. As you can see, when you connect this red one with the positive here, which mean high, and the black one, which is the negative, which mean low in Arduino coding, the motor is rotating this direction. So now what if I want to reverse the direction? What if I want to change the direction? So what I need to do? Simply I need to reverse the connection here. So I will connect this one here and this one here. Remove this one to make it easy to see. Okay, so let's start the simulation and let's see what will happen. Exactly, as you can see, now the motor is changing its direction. So it's moving now this way. Simply to change the direction of a motor, you just need to change the connection here. And if you are writing a code, instead of high you put low, and instead of low you put high. Okay, so now let's do the same here using the Arduino. Go to search, Arduino, drag it here, go to the code, blocks, change it to text, click on continue. Now you need to delete everything inside here. Okay, so as a revision, there are two main functions in Arduino, void setup and void loop. What's written inside here is runs only once. What's written inside here will run repeatedly. Okay, so now let's close this one here and see our connection. We need to remove the battery and also the wires as well. Now let's move this one up here and let's do a new connection here. So we will connect this pen here to pin number 8 and this one to pin number 9. So you can use any pen you want because we have from 0 till 13 digital pens, so you can choose any one of those pens. Now let's go to the code. So why did I remove the battery here? Because I consider this Arduino is connected to the battery from the USB cable here. Okay, so in the void setup here, as usual, you need to locate the pen. So you need to declare the place of every connection to the pen here. So first of all int, and then we need to give it a name. So you can give it any name, but to make it easy for you to follow up, I will use the name that the book used here to follow with me. Okay, so n1 equal to, where did we connect it? In 8, so I will write 8 and then semicolon, and then I will repeat this code again, copy, paste, but this time I need to change 8 to 9, the other connection, and 1 here I will put 2. Okay, the second connection or the second step here is to write the pen mode. So here I need to connect it to the digital pins here. Why? Because the motor will give me output, will give me speed, will give me movement, will give me rotation, so it's output, so I need to connect it here. Okay, and then in the void setup I need to define the mode of the pen, whether it's input or it's output. So since we connected in digital pins here, this digital pins could be inputs or output. You need to decide the mode of that one. So the pen mode, don't forget, it's M capital here, and you will tell me if is it output or input. How to know that? I explained before, if it's a push button, potentiometer, if you are using your hand, or if it is a sensor that collects information from the environment, then it will be input. But if it's give me output, like a brightness, if it's LED, if it give me movements like a motor, or a speed or a rotation like a motor, if it give me sound like a buzzer, and this time I need to put the pin mode as output. So here I need to write pen, M capital, pen mode, and then I will open the bracket here. I need to put the same variable here. You don't make any mistake. If you will make a mistake, just copy the same here and paste it here, and then comma, and then output. As I told you before, if you have two variables here, that means two connections, you need to write here two pin mode also. Here, this is for the first one, and here, should I put it for the second one? Okay, finally in the void loop I need to write the code that will run repeatedly. Okay, so here as a simple connection, I just want the motor to rotate for me. So what do you think I need to do? So in a battery, one was connected to the positive and one was connected to the negative. So what do you think do I have to write here? So in the void loop here, if it is input, you will use this function. If it is output, you will use this function here. So the motor, we both agree that it's output, right? So if it is output, I need to use what? I need to use the write function here. Okay, so which write function, digital or analog here? So we use the digital here if it is only two outputs, 1 or 0, high or low, positive or negative. If you have only two values, we will use digital. If you have different value of speed, you will use analog here. Okay, and of course in between the PWM, if you want to control a speed, if you have a motor, so this is the motor that we were talking about, and if you have to control the brightness of the LED, you will use the PWM. So apparently we need to use the digitalWrite here. Why? Because one pin should be high and the other pin should be low for the motor to move, right? So let's use digitalWrite here. digitalWrite. So don't forget that the W here is capital, everything else is lowercase. So now we need to put the first one here, and then we need to decide whether it's high or low, and then copy this one again for the second one. Okay, so this one for the second one here. So now what do we have to put here to make this motor rotate? If you remember from the previous connection, the motor was connected to the battery, one was connected to high and the other one was connected to low, right? So the same here. So one you should connect it to high and one should you connect it to low. Okay, and then start the simulation. So as you can see, the motor is moving, but it's very slow because the battery here is not high enough for us to move the motor. Okay, but it is moving anyway, and you can see the direction here. Now let's stop the simulation. What if I want to change the direction of this one? What I have to do? So what's really good about the Arduino coding, you don't need to change the wire every time, right? You can only swap here. So let's put this one to low and this one to high. And let's start the simulation. So as we can see now, the direction changed for the motor here. Okay, let me add a battery so we can see the rotation very well. So let's start the simulation here and see the result. So as you can see here, the motor still is not moving or rotating fast. So why do you think is that? Because the Arduino here is working on low current signal. So in this case we need something else to drive the motor here. So the need here is for motor driver. So what is motor driver? Motor driver simply is a device. So as you can see, so this is the motor driver here, and this is a motor driver chip as well. Okay, so they are both doing the same job here. What is the job of the motor driver? So motor driver simply handles the power to drive the motor. So even though the output of the Arduino is low voltage, but when you are using the motor driver here, it will help the motor to be driven, so it will rotate the motor faster here. Also, another benefit of using the motor driver here is to control the speed. So as you can see, there are two pins here, and you still need another wire to control the speed here. So you cannot do this without using the motor driver. We will be dealing with Tinkercad. So in Tinkercad we don't have this one here, but we have the chip. So we will be using this chip here. One thing you need to know about this chip, that you can connect two motors, one motor here and one motor down here. So whatever here is the same here for the second motor. Okay, so the first thing you need to know is the two in the middle here and here, they are the ground. Okay, so you have to be connected, all of them, to the ground. This is number one. Number two, the pin after the ground here and the pin after the ground here is the output. So here we need to connect the output, which is our motor. Okay, then the one after the output here and the one after the output here will be for the input to the Arduino itself. Okay, finally this here is the power, and you have the power here. So this power for the first motor, and this power here is for the second motor. This power will be connected to the voltage here, or the battery. Finally the enable here, so this enable this motor here. We are using this pin here to control the speed. Okay, the same will be for enable 1 and 2 here. So now let's do our connection using the bridge chip. So before we start with the code, with this code here, we need first to start with the circuit here. So we will do the circuit and we will apply our previous code to it. Then we will copy the code and we will understand it together here. Okay, so as you can see, and as I mentioned before, this one here is not there in Tinkercad, so we will be using this chip over here. Okay, second of all, we need to connect this motor and a battery to the Arduino itself. So what exactly will be connected? Pin 8, 9 and 10. Let's see, 8 to input 2, 9 to input 1, 10 to enable 8. So let's do the circuit in Tinkercad. So add Arduino, add the breadboard, add the chip, the driver, the motor driver, just write driver here. This one here you need to put it in the middle here, because all of the lines here are connected together, as you can see, and this line is connected together. So if you put this one here, so the whole line will be connected together, so this one will be connected to this one, which is wrong. They need to be separated, so that's why it should be here. Okay, now add a motor. Finally, we need to add a battery. Sometimes you can add a battery if the Arduino cannot drive the motor here, but I think in this case no need for the battery. Let's check. So let's see the connection here, and the one in the middle, this one are all ground. So this one will be connected to this one and they will be black. This one will be connected to this one. Finally, this one will be connected also to this one. Now from here you need to connect it to the ground. So there are 3 ground pins. So this one ground, this one ground, and this one ground in the Arduino. Okay, second step here is to connect the power. So this is the power here, and here we have another power pin. So let's go and connect it. So this power here with this power here, make it red, and then take from this power here and connect it to pin number 5 volt. And make it red. Now I'm done with the power connection. The second step here is to connect the output and the input. The output between the ground pin should be connected to the motor. So this one should be connected to the motor, just click here, and this one also should be connected to the motor, just click here. Now the input, which is this one here and this one here. So as per the table, input 1 should be connected to pin number 9. So where is input 1? So see, this is input 1. When I put like this, it's input 1. So input 1 should be connected to pin number 9, and input 2, which is this one, should be connected to pin number 8. Output and input yellow, and output and input green. The final point here is to check the enable 1 here. The enable 1 is for the speed, which is this one here. This one, let's make it purple for the speed connection. Now we are done. Let's paste our previous code, the one I just did here. So let's go to block, text continue. Delete everything. So now let's paste our previous code and do the change accordingly. So here we add one line to control the speed of the motor, right? So in order for us to control the speed, we need to know something here. So for us to control the direction, we all agree that we use digitalWrite 2 times, and if we want to swap or to change the direction, we just change low and high here, just swap between them. This way you can change the direction clockwise or anti-clockwise. Now what if I want to control the speed? You will be having a data from 0 to 255, so in this case you're gonna use the analogWrite here, and 255 of course is the maximum speed here. So now since I put a new connection here, I need to define it here. So int, let's make it enable A equal to pin number 10, its place. Since I put something here, what we need to do, I need to add another pen mode, right? And it will be also output because we are talking about a motor here. So let's change the name here to this one here. Paste. Now finally I need to add the analogWrite to control the speed here. analogWrite, and then this one to control the speed is 255. Let me try it with maximum speed here, and let's see the result. Start the simulation. So as you can see here, I'm just checking. So as you can see here, the motor is rotating 9,300 RPM. So almost 9,000 here. The RPM for it. So let's stop the simulation and let's see what will happen if I change here low and here high. So this will change the direction of this one. See, it's not in minus, now it's in positive. So that means it's changing the direction. Now stop the simulation. Now I'm having this one as a maximum speed. So now let me check what will happen if I change this to 155 to make the motor here work at its half speed. So if it's half speed, what I need to do, I need to multiply this by 0.5. Let's see the result here in the RPM. So see, it's almost half speed, 4,000 something. It was 9,000 because now I divided into its half speed. Let's stop the simulation. Now let's see what if I want it to be off. I will give it 0 speed here, 0 speed, and let's see, as you can see, 0 RPM, so no movement at all. Stop the simulation and let's go to our code. Click OK, copy this code here, go to the Arduino and paste it. So let's understand the code here. So the connection is input 1 is connected to pin number 9, input 2 is connected to pin number 8, the yellow one here, and the pin, the enable 1 and 2, which is enable A, is connected to pin number 10. Of course, this 2 is for the output, connected to the motor, and finally all the grounds are connected together and all the powers are connected together here. So here we put the pin mode for all of them. They are all output because we are dealing with motor here. Now the stage 1 is to make it full speed. Full speed, this means digitalWrite high low for the direction, and of course this one for the maximum speed, which is 255. And then we want to make it 5 seconds, and then we want the speed to be decreased and work at its 70% speed. So 70%, it means 0.7 multiplied by 255. The stage 2 here is to change the direction. What do we need to do to change the direction? We just swap high or low here. Okay, then we need to make the analog to run it's half speed, so you need to put 128 or 255 multiplied by 0.5. But let's make the Arduino calculate it for us. Okay, and make it for 5 seconds. Finally, we want the motor to be off. You just make everything low and make the speed also low. Now let's start the simulation and see what will happen. So first of all, see full speed, and then 0.70 speed, then half speed, change the direction, then 0 for 5 another second. So this is the output here. Stop the simulation, take a screenshot and upload it. Now let's go to the second step, which is modify the code by adding a stage where a motor runs 30% of its speed in any direction. So it doesn't matter which direction it is. So in this case, just add here for a comment. So motor at 30% speed. So this one, it will not affect the code here. Now let's make it for 30%. Let's copy this one, so we will not change many things here. Make one of it high. It doesn't matter because they said in any direction. So let me make this one high. And then the enable here 30%, so 255 multiplied by 0.3, and then close it and then semicolon. And let's start the simulation. So of course everything full speed, and then 0.7 speed, 70% speed, and then for 5 seconds, and then we'll change the direction, 50% speed, and then we'll stop for 5 seconds, and then we'll work with 30%. So you see the number here, 30% speed. So take a screenshot and let's move to the second question. Finally, use if else statement to have the code check a condition and act accordingly. Declare a variable x with any value. Compare x to 10. If x is more than 10, run the motor at 75, else 25%. So let's stop the simulation here. Delete everything except the thing we just add here. So delete everything here and just leave this one here. So we have two conditions. This condition, so we have two conditions. One condition and second condition. The first condition, the motor work at 75 speed. So here 75, and here 25. Of course, here you need to put the if condition. So if x is more than 10, do something, else do something. So what is x? I need to declare it here. So x and x equal number, so we can give it any number here. Let's make it 50 and then semicolon. If x is more than 10, run at 75%. So let's copy this one here, cut it and put it here. Else run at 25%. So cut this one here and put it inside here. And let's start the simulation and see at what speed the connection will work. So it's working apparently at 75% speed. Why? Because x is 50 and it is more than 10. Now let's stop the simulation and make it 5, which is less than 10. It should work on 0.25 speed, so it should be like 2000 something here. So let's see, will it work like this? Yes, exactly. So 2000 something here, that means it's working on this direction. In this case, I need two screenshots, one shot when it's 50 and one when it's 5. Or you can choose any number that show me the two condition here. That's it for today. Good luck.